Okay, so let's start the break. So now we are just going to quickly conclude this over OSI, and then we will move to the next model, which is the let's take internet layer or TCP/IP. So a real example of how we send the email. So like suppose at application layer we write the email. Dear Mr. Do XYZ, then presentation layer make it how it will be sent, then session layer break these, make the connection, create the session, then transport layer make sure that how this connection is established between the two, what we say the application and we could make send, the network layer make sure that how bits and bytes sent on the network data transfer, and data link between the link devices and physical layer will literally the bits and bytes means zeros and ones. Okay, so for the key takeaway of this specific portion of OSI, the OSI model provides a structured framework for understanding network communication. Each OSI layer has a specific function that interact with the adjacent layer to facilitate communication. So, in analogy, visualizing and understanding the concept of each layer. And then in conclusion, understanding the OSI model is essential for network engineers and developers to design, troubleshoot, and optimize network communication. So let's move forward. So now we are going to explore the TCP IP protocol soon. So just to make it clear that in network there are different layer models is used. So TCP IP is sort of the internet layer we just discussed in the start of the network. So TCP IP transmission control protocol, internet protocol is a primary protocol suite designed for modern networking. So it provides foundation for communication on the internet and many other networks. So comparison with OSI, unlike the OSI model which consists of 7 layers, TCP comprises 4 layers. You remember that in the start of the section, I discussed some architecture which is from the book of Cruz and Cross, uh, top-down approach, computer networking, top-down approach. So they use this term as an internet layer model or internet layer. So they present 5 layers for it, but usually TCP IP layers are 4 layers. So 4 layers network interface, internet, transport, and application layer. So key differences. So for OSI model, number of layers 7. For TCP IP, number of layer are 4. Focus is conceptual framework. This is a practical implementation. TCP IP layer, which runs mostly internet. Network interface layers, data link and physical. And in the TCP IP, only the network interface. Transport layer, transport and session. And here it's only the transport layer. Okay, so we are going to review quickly the TCP IP layer. So network interface layer responsible for physical transmission of data over the internet includes Ethernet, Wi-Fi, and point-to-point protocol. So now here you see that from the OSI reference model, the many layers are presented in one layer, which is called network interface. Then internet layers handles addressing and routing of data packets across different networks. So uses IP Internet Protocol and ICMP, Internet Control Message Protocol. ICMP protocol is used between the network devices to make sure the smooth connectivity during the sending and receiving the packet. So routers use this protocol to communicate between transport layer. So ensures reliable and efficient delivery of the network data include TCP and IP, same as the the OSI transport layer. Then application layer provide application and end user. So it include HTTP, FTP, SMTP, same as the previously. So TCP IP layers as a postal system. So network interface delivery person like Ethernet or Wi-Fi ensures data reaches to the correct. It is like a delivery person. Then internet layer is like a street signs, IP address and all data, correct neighborhood. Transport layer is like, the delivery truck. TCP UDP ensures safe transport of packets. Application connects the packages HTTP and the content of the packet. So there is an example. We have been using this again. You are using this example. So application layer user composes an email using an email client like Outlook X. And then transport layer TCP breaks the email into the packets, adds sequence number, and send it to over the internet using the infrastructure. Then IP layer addresses are used to route the packets to the recipient's email server. So then network interface layer, Ethernet or Wi-Fi transmit the packets over the physical networks. Another example of browsing the web. So application layer uses request a web page using a web browser, Chrome, etc. Transport layer, TCP establish a connection with the web server and ensures the reliable data transfer. Internet layer, IP layer, IP addresses are used to route the packets to the web server IP address, and network interface layer, Ethernet or Wi-Fi transmit the packet over the physical network. So TCP/IP is a fundamental protocol suite in modern networking, providing reliable communication over the internet and other networks. So understanding the TCP layer and their functionality is essential for network professionals and the developers. So real world example of protocol stack. It is we just discussed the same example. We will just go through quickly again. Various application and servers of the network. Example include sending email, we just discussed, and browsing and web video conferencing, etc. So sending an email SMTP or over TCP/IP, simple mail transfer protocol used for sending emails over a network. So email communication involves multiple layers of protocol stacks, including application layer, SMTP protocol, and transport layer, TCP/IP protocol. So these are some example of steps. So application layer, SMTP protocol uses user composes email, then transport layer, TCP/IP protocol, establish connection and send reliable data transfer. We just discussed this concept of reliable data transfer. So it is important to understand the key terminologies. So reliable data transfer means that makes sure that there is no packet lost and all packets, if there is lost, then it is resent. And then in the case of delay and other things, this protocol defines many things. So internet layer TCP IP address are used to route the packet and recipient, and network layer Ethernet or Wi-Fi. So we discussed this example again. Same for the web browser as well. And we just discuss a final what we call the video conferencing example. So that is also an example of the protocol. So how it works? Video conferencing. So video conferencing uses the RTP or real-time transfer protocol used for streaming audio and video over the network. So video conferencing involves real communication across different layers of the protocol also. So steps, application layer protocol RTP uses the video call, conferencing software, and transport layer protocol UDP IP. Here we use UDP, user datagram protocol. We just discussed this in previous part of our lecture as well, that user datagram used for the live streaming and video conferencing. So then internet layer UDP IP also uses the IP address are used to route the protocol, and network layer UDP IP Ethernet or Wi-Fi transports the packet. Okay, so we have some analogy again, like suppose sending mail through the postal mail, it's example of communication, and then each layer protocol stack correspond to a steps in a postal process from writing a letter application to delivery postal service network. And these are some analogies to understand. Now we move forward to the use of this, the practical applications protocol. So practical applications of protocols, practical takes, particular TCP vital role in various aspects of modern networking. Here is some example, like suppose, the building and troubleshooting a network. So network engineers basically leverage all these things. So like the we design networks, we design infrastructure for appropriate physical media we use, what sort of Ethernet card will be used, what network devices will be used, switches, routers, all these requirements. And then internet layer focuses on IP addressing scheme like public versus private, but sort of the using ensure make sure that what. And then security protocols like firewalls, intrusion detection system, all this require the network design requires uh, the internet, uh, what we say, the engineers to address these things. Then network configuration techniques like the switching using SNMP protocol, simple network management protocol, that also required. Then troubleshooting, for troubleshooting of the networks when network issue arises, so professional isolate the problems using some specific data flows and understanding of the protocols. Okay, so then also for development, you must know all these protocols for the development. If you are developing an application, so either it's a server end application or the user end application, you must know the protocols like application layer protocol, HTTP, FTP, SMTP, what sort of application you are going to develop. So So then web developers, you must know the HTTP and all these things. If you don't do, so you will not be able to create a good app. Mobile app develop protocol like TCP, UDP to establish the connection, transfer the data between the servers and the mobile device. So then understanding of this, so all these, the related issues of practical applications in the protocol stacks. So you should know the understanding how protocols functions for different devices. Then also for the network services like DNS or DHCP, domain name service system, domain name system, or dynamic host configuration protocol, they also require the understanding of the networks. Then additional application like network security management, all these things require to better understanding of the protocol stacks to develop the proper, the protocols. Okay, just final, just 1 minute more. I need to discuss a summary. Okay, sorry for interruption. So this is my final slide for today's lecture. So in this today's lecture, we have explored the concept of protocol stacks, like the OSI and TCP/IP. Then their significance in the modern networking. So what is some protocol stack like TCP/IP provide a structured framework, network communication, ensuring data is transferred efficiently and reliably. Then each layer within the protocol stack performs a specific function, contributing to overall functionality of a communication network. Then understanding protocol stack is essential for network professional and developers for various tasks, like we just discussed, building and troubleshooting network infrastructure, developing network application and services, implementing network security measures. Okay, so by learning about these protocol stacks, you gain a deeper appreciation of complex yet efficient technical process that power everyday network infrastructure. So this concludes our exploration of protocol stacks. So feel free to ask any questions. Anyone? So that is the end of today's material. Now we do some discussion or questions. Anything you want to discuss? Nothing? So write something in the chat. Okay, regarding the notes, yes, I will share these slides. Last week I couldn't share, sorry about this, and today I will make sure to share these lecture slides, previous lecture slides as well, and I will try to share some books as well. Okay, so